Hello, my dear students. Welcome to IMS Gate Academy. How are you all? I am welcoming all of you for the GATE PYQ series of communication system subject. So, in the earlier sessions, we have discussed the recent 5 years GATE questions, selected questions from the latest 5 years, right? So, we have discussed variety of GATE questions in the previous sessions. I hope by this time all of you got the confidence. To increase further confidence, we are continuing further. In this particular session, I am going to discuss the selected questions which are asked in the GATE 2018, which are helpful for both the branches, electronics and communication and instrumentation as well. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session, right? Whoever couldn't attended earlier sessions, no issue at all. Whatever the sessions happened earlier, those recorded lectures will be available in our playlist. Okay, so kindly check, type in the YouTube, type IMS Gate Academy, and after that just check the playlist. Okay, so regarding communication system subject, you can see the previous year questions playlist. So there we have discussed regarding the latest 5 years GATE questions. Okay, so whoever missed those sessions, kindly watch those sessions, and in this particular session I am dedicating, okay, I am dedicating regarding GATE 2018 selected questions. Okay, similarly on tomorrow we are having one more session. So in that session I will discuss the GATE questions related to 2017. Okay, right. So this is the question asked in GATE 2018 for 1 mark. This is the question related to amplitude modulation. So all of you give a try. Yeah, time up. Whatever the answer you are getting, you can mention in the chart. Okay, no issue at all. Even if you are mentioning wrong answer, no issue at all. There is no negative marking, right? So during our classes, whatever the answer after solving any question, whatever the answer you are getting, you can mention in the chart. If it is correct, fine. If due to any reason, okay, due to calculation mistake or any issue, somehow or other if you get wrong answer, no issue at all. Later when I'm explaining, so that time you can cross check, you can correct where you had done the mistake. Okay, so whenever you are doing any mistake, you are getting the opportunity to learn something new, right? So don't hesitate while answering. Okay, so whatever the answer you are getting, you can mention in the chart, right? So in this particular question, they have given one equation. This equation is corresponding to amplitude modulated signal, right? So here you're having cos 2000 pi t plus 4 cos 2400 pi t plus cos 2800 pi t, right? They have given the equation of AM signal like this, and now they're asking ratio of the power of the message signal to the power of the carrier signal, right? So for understanding purpose, I will discuss this question in the conventional approach first, and then I will discuss the shortcut method. With the help of shortcut method, you can easily solve this question without using pen and paper, and in fact you can answer this question in less time. Okay, I will discuss the shortcut in some time. First I will explain this question in the conventional approach, right? So whatever the equation they have given, I have written here as it is, the same equation. This is the AM signal they have given. So for the time being, I am just modifying this particular given equation into the standard format, right? So here just observe the frequency terms. Here you are having 2000 pi t, here 2400 pi t, here 2800 pi t, right? So among these three 2400 pi is the intermediate, right? When compared this one, this is greater. When compared this one, this is lower or smaller, right? So this term we can keep as it is. Okay, why I am keeping this term as it is, you will come to know in some time, right? So for the timing, I am copying this term as it is. 4 cos 2400 pi t. 4 cos 2400 pi t. The middle term I have copied as it is. Okay. Now the last term I am writing. I am modifying like this. Cos. Just observe. Here you are having 2400 pi t. When compared to that one, here this term you are having 400 pi t extra, right? So this one we can write like this. 2400 plus 400 pi t. See here cos 2400 pi t, here 2800 pi t you are having. That one I have written like this, 2400 plus 400, that together is nothing but 2800, right? Similarly this term I am writing here, cos. Now can you tell how we can write 2000 pi t? Yes, it is very simple. Here you are having 2400 pi t, right? So first I am writing this term 2400 minus 400. 2400 minus 400 is nothing but 2000, and then you are having pi t. Okay, right. So first term you can copy as it is, 4 cos 2400 pi t. First term you can copy as it is. Now second and third terms if you observe, like cos sum plus cos difference format you are getting. Can you recall the standard trigonometric equation? Cos sum plus cos difference, we can write it as, any guess? Cos sum plus cos difference, how we can write? We can write it as 2 cos A cos B, yes or no? 2 cos A cos B is nothing but cos sum plus cos difference. here you are getting some term, here you are getting difference term. Okay, whatever the two cos terms you are having, you can multiply and then multiply with 2 also, right? 2 cos, here a is nothing but 2400 pi t, 2400 pi t. And then cos b is nothing but 400 pi t, 400 pi t. I hope it is clear for everyone up to this step. If you are having any doubt, you can mention in the chat. I will repeat once again. By using this trigonometric equation, 2 cos A cos B is nothing but cos sum plus cos difference. Okay. So here we are having cos sum plus cos difference. That one we can write as 2 cos A cos B. Here A is nothing but 2400 pi t, B is nothing but 400 pi t. Now can we take anything common from these two terms? Can we take anything common? Just observe. Yes, we can take here cos 2400 pi t. Cos 2400 pi t we can take common, and here you are having for this particular signal amplitude is 4, that 4 also we can take common. Accordingly you will get some factor here, right? So here I am taking 4 cos 2400 pi t as common. Okay, that means the entire first term I have taken it as common. So that means here I will get simply 1 into this term is nothing but this term, right? Plus here 2 is there, but here I have taken 4. Can you tell what is the factor I have to consider here? Multiplication factor. Here actually 2 we are having, but I have taken 4. That means I have to multiply with 1 by 2. Yes or no? 4 into 1 by 2 is nothing but 2. 4 into 1 by 2 is nothing but 2. And then cos 2400 pi t we already taken common. Now the leftover term is cos 400 pi t. Cos 400 pi t, right? Now whatever the equation here you got, now you can check with your standard equation of AM signal. You are having the standard equation of AM signal as S of t equal to AC cos 2 pi FCT into 1 plus mu cos 2 pi FM into t. See, we are having the standard equation of AM in various forms. Okay, this is one of the standard equation. Okay, here you are having AC cos 2 pi FCT. Okay, into 1 plus mu cos 2 pi FM into t. Right. So when you compare these two equations, AC value you are going to get 4 volts. AC you are getting 4 volts. And what about the modulation index? Modulation index is nothing but 1 by 2. Which is nothing but 0.5. Right. So up to here we got whatever the given equation is there regarding AM. So I have represented into one of the standard form of the AM equation, right? So from here we got AC value and mu value, and similarly you can calculate FC and FM, but for this question FC and FM are not required, that's why I am not calculating, but otherwise you can calculate. Okay, later in your free time calculate FC value and FM value, right? So for this question what they are asking, just observe here, last 2 lines or 3 lines, just read. They are asking the ratio of power of the message signal to the power of the carrier signal. Now can you tell what is the power of the message signal in AM? In AM, what is the power of the message signal? Any guess? See, I hope all of you know the standard equation regarding the power, how much power required for transmitting an AM signal. Can you recall? Yes. The power required for transmitting an AM signal is PT, which is equal to PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. Okay, for the timing just multiply PC with both the terms. from here you will get PC plus PC into mu square by 2, PC plus PC mu square by 2, right? So here PC is nothing but carrier power, PC is nothing but carrier power, and then PC mu square by 2 is nothing but the total sideband power, the total sideband power. In AM signal we are having the carrier frequency component, and along with that we are having both the sidebands, right? So in AM signal or DSBS signal, the message signal is nothing but the total sideband together, both the sidebands. Whereas in SSBS signal, if they ask, oh, okay, in SSBS signal means the message signal power is nothing but only one of the sideband. Okay, so that one you have to take care. Okay, generally students used to get confusion. In general, ideally speaking, the message signal is available in any one of the sideband. Either you can consider upper sideband or you can consider lower sideband, because both the sidebands, with the help of any sideband, you will get the same information, right? But whenever the questions regarding AM signal or DSBS signal, whenever they have mentioned that message signal power means, because we are transmitting both the sidebands, okay, and in fact in both the sidebands you are having the message information, so that is the reason whenever they mention message signal power, which is nothing but total sideband power. Whereas in SSBS signal, the message signal power is nothing but half of the total sideband power, because there we are transmitting only one of the sideband, right? We are suppressing one carrier component and we are suppressing one of the sideband also, right? Okay, so that means here according to the given question, they have mentioned that ratio, we have to calculate ratio of power of the message signal to the power of the carrier signal, right? Power of the message signal to the power of the carrier signal. Power of the message signal in AM or DSBSC is nothing but total sideband power. Total sideband power divided by, here they are asking the ratio with respect to carrier power. Okay. Now total sideband power is nothing but PC mu square by 2. So substitute here PC mu square by 2 divided by, here you can keep PC as it is. So PC will get cancelled. That means you are going to get mu square by 2. Now just substitute mu value, that's all. Just substitute mu value and do the simplification. From there you will get the overall value. So just now we got mu value as 1 by 2. So 1 by 2 you can substitute here. 1 by 2 whole square divided by 2. 1 by 2 whole square is nothing but 1 by 4 divided by 2. Don't do silly mistake here. 2 2s are 4, because both 4 and 2 are in the denominator only. Yes or no? Both 4 and 2 are in the denominator. So 4 2s are 8. Okay. So 1 by 8 is nothing but 0.125. 1 by 8 is nothing but 0.125. See, 1 by 2 value is how much? 1 by 2 is 0.5. 1 by 4, which is nothing but 1 by 2 divided by 2. So that is nothing but 0.5 divided by 2. That is nothing but 0.25. 0.25. Right. If you are dividing 1 by 4 with 2, you will get 1 by 8. That means 0.25 divided by 2. How much you are going to get? 0.25 divided by 2, which is nothing but 0.125. In this way, whenever you are having simple calculations, okay, don't depend on the calculator. Okay, of course, if you are using calculator, definitely you will get the answer. But if you want to increase your IQ level, if you want to increase the speed of doing the calculations, you know, in a faster rate, okay, whenever you are having simple calculations, try to solve like this, so that it is not only benefiting regarding your technical questions, it is indirectly it is helping regarding aptitude questions also, right? So if you want to attempt any question, in less time, so wherever calculations definitely possible without using calculator, try to do. Okay, so for whichever calculations definitely it is a laborious or time taking, definitely that time you can use the virtual calculator or normal calculator. Okay, right. So definitely if you are depending on the calculator, that means, okay, whenever simple calculations are there, better do it by your own. Okay, and and one more important thing, without using pen and paper also. Okay, so that whatever this simple calculation is there, for understanding purpose I have written on the board, but this simple calculation if you are able to do in the mind level, you are increasing the speed, right? Definitely if you are able to attempt good number of questions correctly in less time, that means you are having the great opportunity to score more marks in the GATE exam, right? Yeah. So here for understanding purpose I have solved this question completely in the conventional approach. Now as I have mentioned at the beginning of this particular question, we can solve this question without using pen and paper. Okay, right. For that, if you know the standard equation of AM signal, if you know that standard equation without using pen and paper, you can directly answer this question in less time, right? So here just observe, you're having this is one of the standard equation regarding AM, AC into cos 2 pi fct into 1 plus mu cos 2 pi fm into t. Okay, for the timing I am considering this equation. For understanding purpose I will write 2 or 3 steps. Okay, but that after doing 2 or 3 steps, what are the equation we are getting, if you are able to at least recall, no need of exactly same format, but at least if you are able to recall the format, the standard equation of AM signal, from there also you can easily answer this question without using pen and paper, right? Okay, so for the timing I am considering this equation. Okay, I am considering this equation. Whatever I have explained here, this is the method 1. Now I am discussing the second method. Method 2. So what is standard equation here we are getting? Okay, this equation I am copying now. Okay, I will write once again. S of t equal to AC into cos 2 pi fct into 1 plus, can you recall? Yes, mu into cos 2 pi fm into t. All of you cross check once quickly. Yes, S of t equal to AC cos 2 pi fct into 1 plus mu into cos 2 pi fm into t. S of t equal to AC cos 2 pi fct into 1 plus mu into cos 2 pi fm into t, right? So for the timing, expand this term, that means multiply this term with both AC cos 2 pi fct with 1 and AC cos 2 pi fct with this term, right? So from here what you will get, AC cos 2 pi fct, AC cos 2 pi fct plus AC mu cos 2 pi fct into cos 2 pi fm into t. AC mu cos 2 pi fct into cos 2 pi fm into t. Okay, now you are getting in the standard form, one of the standard equation of trigonometric equation, right? You are having like 2 cos A cos B, right? So here for the timing we don't have 2, so that means I am multiplying and dividing with 2. I am just multiplying and dividing with 2 so that we can get the standard equation, one of the standard equation regarding trigonometry. Yes, 2 cos A cos B, 2 cos A cos B. I hope all of you know the formula. 2 cos A cos B. And in fact earlier also I have written regarding that one. 2 cos A cos B is nothing but cos sum plus cos difference. 2 cos A cos B is nothing but cos sum plus cos difference. Okay, now we can use this formula. So first term we can copy as it is. S of t equal to AC cos 2 pi fct plus AC mu by 2 we can copy as it is. AC mu by 2 we can copy as it is. Now you are getting 2 cos A, that means this is A, this is B. 2 cos A cos B, right? So we can perform like cos sum plus cos difference, right? cos sum, that means 2 pi fct plus 2 pi fm into t. So we can take 2 pi t as common, right? So 2 pi into fc plus fm into t, fc plus fm into t, right? Plus the same coefficient you will be having, because 2 cos a cos b, 2 cos a cos b is nothing but cos sum plus cos difference, right? For this overall term you are having this the coefficient, right, or amplitude, you can say AC mu by 2. Okay, so AC mu by 2 as it is. Now cos difference, that means you will get 2 pi into fc minus fm into t. All of you please respond, is it clear up to this point? All of you quickly respond. If you are having any doubt, I will repeat. Yes, I hope it is clear, right? Yeah. So here you are having AC cos 2 pi fct plus AC mu by 2 into cos 2 pi into fc plus fm into t plus AC mu by 2 into cos 2 pi into fc minus fm into t. So if you carefully observe, whenever you are having AM signal, so you will be having total 3 terms. In that, one of the term will be having the carrier frequency component, that is fc. In one of the other terms, you will be having upper sideband frequency, that is nothing but fc plus fm. So fc plus fm is nothing but upper sideband frequency. Similarly, fc minus fm is nothing but lower sideband frequency. So you are having both the sidebands and along with that the carrier frequency component. So that is nothing but your standard equation of AM, amplitude modulation, right? You are having both the sidebands and then along with that carrier signal, right? So in this way, whenever you are having the time domain equation, okay, just by observing the frequency components, you can guess that which term is related to the carrier component, which term is related to the upper sideband, which term is related to the lower sideband. This is one of the observation. And one more observation. As I mentioned earlier, both lower sideband and upper sideband will be having the similar type of information. Yes or no? Yes. Okay. So that is the reason. Now you can observe closely. If you observe, regarding these two terms, the amplitude you are having AC mu by 2. Whereas regarding cos 2 pi fct, carrier component, you are having the amplitude as AC. Okay. So what I mean to say, whenever you are having the standard equation of AM signal, okay, here this is the standard equation of AM signal, but in the question they will represent in terms of values, right? So among the 3 terms, okay, which term you can identify that is a carrier component, which terms are related to the sideband. Okay, I am given the 2 ways. By using in any one way, you can easily identify. The earlier method I have mentioned with respect to the frequency components, you can easily understand. Okay, right. So just observe and tell me. Here we are having 3 frequencies. One is fc, another one is fc plus fm, another one is fc minus fm. So when you observe these 3 frequencies, obviously this is the maximum. This is the maximum frequency, and this is the minimum frequency. This is the maximum frequency and this is the minimum frequency. So among those 3 frequencies, whichever is the maximum frequency, that is the upper sideband frequency, whichever is the minimum frequency, that is the lower sideband frequency, and whichever is like intermediate, that is nothing but your carrier frequency. Okay, that is one method you can easily identify. And one more hint I am giving, you can observe among those 3 terms, cos terms or sin terms, okay, whichever two terms are having the same amplitude, those are nothing but sideband. Simple. See, just observe, these 2 are having the same amplitude, that means these 2 are related to the sidebands. Okay, whichever term is having different amplitude, that is nothing but simply carrier. Okay, this is another way, right? Okay. Now with this understanding, now just if you observe the given equation, here you are having cos 2000 pi t, 4 cos 2400 pi t, and cos 2800 pi t. Okay, with respect to the frequencies, you can observe 2800 pi t is the upper sideband, 2000 is the lower sideband, and 2400 is the carrier frequency. Or in other words, these 2 are having what? same amplitude? Yes or no? Here amplitude is 1, here also amplitude is 1. So that means the first and third terms are related to the side bands, whereas the middle term is related to the carrier component. So in that way also you can easily correlate. Okay, right. So once again I am writing the given equation. S of t equal to cos 2000 pi t S of t equal to cos 2000 pi t plus 4 cos 2400 pi t plus cos 2800 pi t. This is the equation given. Yes or no? Right. So from here, if you observe this term and this term, both are having the same amplitude. Okay. So that means these two are related to side bands. Okay. Whereas the middle term related to the carrier. Okay, right. Now just observe this standard equation. What is standard equation here you got? You have to remember. Okay, no need to by heart the entire equation. Simple. Regarding cos signal or carrier signal, obviously you will be having carrier amplitude as what? AC. Okay. Here regarding upper sideband or lower sideband, with the help of any term, okay, the same amplitude you will be having. Right? That is nothing but AC mu by 2. AC mu by 2. Okay. So AC mu by 2 is nothing but here 1. AC mu by 2 is nothing but 1. Whereas AC is nothing but 4. See, this is AC cos 2 pi FCT format. Here AC mu by 2, here also AC mu by 2. After that, here you are having like cos 2 pi into FC plus FM into T. Here cos 2 pi into FC minus FM into T. Okay, right. So AC value you can substitute here. 4 into mu divided by 2 is equal to 1. Here 2 times. That means mu value you are going to get 1 by 2. Okay. Once if you know the standard equation, regarding those three terms, one is carrier and other two are related to side bands. Okay, related to side bands, both the terms will be having the same amplitude, right? Whichever terms are having the same amplitude, just observe that one, any one term. Okay, so here in this particular equation, the first term and last term are having, both are having same amplitude, that is nothing but 1. That is nothing but here, according to our standard equation, that is nothing but your AC mu by 2. And whichever term is having different amplitude, that is nothing but that particular term amplitude is nothing but AC. Okay, with the help of this one, you can calculate mu value. Once if you are able to calculate mu value, after that what they are asking? They are asking ratio of message signal power and carrier power, right? So that is nothing but total sideband power divided by carrier power. From here what you are getting finally? Mu square by 2. Okay, this formula you know, right? PC into 1 plus mu square by 2. Okay, so this term is nothing but total sideband power and this is the carrier power. They are asking simply ratio of these two. So that means PC will get cancelled. You are getting mu square by 2. That's all. Mu square by 2. You are getting simply mu square by 2. Now you can substitute mu value 1 by 2 here. That's all. 1 by 2 whole square divided by 2. So this calculation we already done. So the final answer for this question is 0.125. How much time it will take? Whether we require really pen and paper for solving this question? All of you respond. Whoever watching this lecture later, so you can mention your answer for this question. Whether do we require really pen and paper for solving this question? So you can mention that in the comment section. Okay. So we no need to use pen and paper for solving this question. In fact, we can answer this question in less time. Okay, that is the beauty of regarding amplitude modulation questions. Okay, just if you observe carefully regarding the equation given, try to compare with the standard equation. Okay, so in the communication system subject, you will be having lot of equations, but okay, but generally students will think that, sir, how we can remember lot of equations. Okay, so if, as I mentioned in one of the earlier sessions also, if you want to by heart, okay, if you want to remember the formulas, if you are doing the by heart, then you may remember for short run, but after few days you may forget. But if you want to remember the formulas for long time, try to solve good number of questions. While solving the questions, if you are applying the formulas, you will get the familiarity about the formulas. Okay, right. So if you observe carefully regarding the AM, in this particular question, I have given two standard equations. If you closely observe, this is one of the standard equation, this is one of the standard equation, and earlier we have discussed one more standard equation. This is one more standard equation. Okay, so the other equation is just derived version of the earlier one. Okay, so in this way, according to the context and requirement, we can use any standard equation related to AM, and in this way you can easily solve the question related to AM, right? I hope all of you got the clarity. So with this understanding, all of you give a try. The next question I will show, all of you give a try. Yeah, time up. Whatever the answer you are getting, you can mention the chat. Whoever watching this lecture later, okay, so you can mention your answer in the comment section. Okay, so before watching the explanation part, so try to solve this question, and whatever the answer you are getting, you can mention in the comment section, right? Yeah, see the beauty of these two questions. Both the questions related to the same concept, amplitude modulation only, and in fact both the questions are asked in the same year, same branch. Okay, in the year 2018 for EC branch, the previous question weightage is 1 mark, whereas this question weightage is 2 marks. Okay, so up to here they have mentioned some information, but after that if you read last 2 or 3 lines, from there this question and the previous question are like same model, similar model, we can say. Okay, but in the previous question directly they have given the AM signal, but in this question they want to generate the AM signal. Okay, so for that they have given the information how they are going to produce. Okay, so read carefully line by line. Here you are having the carrier signal C of t equal to AC cos 2 pi f ct, and the message signal they have given cos 2 pi f m into t. In general you will be having AM cos 2 pi f m into t, but here in this case amplitude of the message signal as 1 volt. Now they have given the relation between the carrier frequency and message signal frequency like this: Fc far greater than 5 times Fm. We already know that the carrier frequency obviously is far greater than when compared to the message signal frequency, right? The signal they have mentioned carrier signal plus message signal C of t plus M of t is applied to the input of a non-linear device. Here they have given the relation between the input and output. Here output of this non-linear device as V0 of t and input as VA of t. The relation they have given A times VA of t plus B into VI square of t. Okay, so this is the relation between output and input. Okay, here A and B are the positive constants. The output of the nonlinear device is passed through an ideal band pass filter which is having the center frequency Fc and bandwidth. See, whenever you are having the band pass filter or any filter for that matter, it will be having some band of frequencies. It will pass some certain band of frequencies, it will reject other band of frequency, right? So here in the band pass filter, the center frequency is Fc and the bandwidth is 3 FM. That means it is passing some band of frequencies, right? Okay, so it as the name implies, band pass filter, it is passing only some band of frequencies centered around Fc. That means it will be having upper cutoff frequency and it will be having lower cutoff frequency, right? So the difference between upper cutoff frequency and lower cutoff frequency is nothing but bandwidth. So that one they have mentioned as 3 times Fm. Okay, here this band pass filter they are using to produce an AM signal, to produce an AM wave. Okay, after that they have mentioned one condition, right? If it is desired to have the sideband power of the AM signal to be half of the carrier power, then A by B is dash. Okay, so regarding that they have given 4 choices, you have to choose the correct one, right? So first of all, let us solve this question step by step. Okay, right. So here message signal is there, carrier signal is there, we have to consider C of t plus M of t. Okay, C of t plus M of t, which is nothing but C of t is nothing but AC cos 2 pi f ct. AC cos 2 pi f ct, whereas message signal is nothing but cos 2 pi fm into t, cos 2 pi fm into t. Okay, right, they have given carrier signal like this, message signal like this, and they have combined C of t plus M of t is nothing but you are going to get like this. Now they have given the relation between input and output of nonlinear device like this. Output of nonlinear device here they have mentioned V0 of t equal to A into VA of t plus B into VA square of t. V0 of t is equal to A into VA of t plus B into VI square of t. Yes or no? A into VA of t plus B into VA square of t. According to this question, they have mentioned this C of t plus M of t as an input to this nonlinear device. That means your VI of t is nothing but C of t plus M of t. According to this question, C of t plus M of t is nothing but the input for this nonlinear device, right? So here wherever V of t is there, substitute this entire expression. Okay, so for the timing, first I will write this one. After that, later directly we can substitute this one. Okay, right. So that means here we are going to get V naught of t equal to A into. Otherwise, if you want, you can directly substitute this entire expression, no problem, because V of t is nothing but C of t plus M of t, whereas C of t plus M of t is nothing but this entire expression. Okay, if you want, you can directly substitute this entire expression in place of V of t. Okay, right. So for the timing, I am directly substituting this expression. Okay, so that we can save the number of steps, right? So here V of t is nothing but this entire term AC into cos 2 pi f ct plus cos 2 pi fm into t, cos 2 pi fm into t. Okay, so this is in place of V of t we have substituted, right? Similarly here you are having plus b into Vi square of t, that is nothing but Vi of t whole square we can write, right? Whereas V of t is nothing but this entire term whole square. That means you are getting like a plus b whole square format. Yes or no? This is the first term a, this is second term b. Otherwise you can consider like x plus y whole square, which is nothing but x square plus y square plus 2xy, right? So I am directly writing the direct step. Okay, instead of substituting in this term and then after that I am expanding the term, instead of that directly I am writing x plus y whole square format. Okay, so that means first term square AC square cos square 2 pi f ct, that is the first term square, plus second term square is nothing but cos square 2 pi fm into t. Okay, x square plus y square plus 2xy. That means you have to just multiply these two terms. What you are going to get? AC cos 2 pi f ct AC cos 2 pi f ct into cos 2 pi fm into t. Is it clear for everyone? See here you are having VA of t, I have directly written. Similarly here also I have to substitute this entire term. After that I have to perform square, but I have written direct step because you are having x plus y format. X plus y whole square is nothing but x square plus y square plus 2xy. I hope it is clear for everyone, right? Okay, now this is the term you are going to get. Okay, this is the term you are going to get. We can do further expansion. Okay, so just observe, up to here we got the equation like this. Okay, we can do further expansion, but that expansion we will do for the selective terms only. Instead of writing this entire equation elaborately, okay, we'll focus term by term only. Okay, right. So just observe here, whatever the output of this nonlinear device you got, that one they have passed through an ideal band pass filter. They have passed through an ideal band pass filter, okay, which is having a center frequency FC. Okay, so that means here you are having the band pass filter transfer function like this. So here center frequency is FC. It is passing this range of frequencies, that's all. So this range of frequencies they have mentioned 3 times FM. 3 times FM. See here, they have mentioned bandwidth of that particular filter as 3 FM. 3 FM. Okay. So center frequency is FC. It is passing some band of frequencies this side and some band of frequency this side. Okay. Together you are having this much band. That's all. Okay. Right. Now if you carefully observe, here you are having FC term. Obviously it will pass. Okay. Yes or no? This center frequency FC you are having, and lower cutoff frequency you are having, and upper cutoff frequency you are having. Yes. Obviously this particular term the band pass filter will allow. Now tell me whether this particular term will pass by the band pass filter. No, because here FM is what? Very low frequency when compared to FC. Yes or no? Say for example, if you are expanding this particular term, okay, so here you will be having 0 and somewhere here you will be having FM. Okay, so this FM is not there in this particular range of frequency, right? So obviously this particular term won't allow by the band pass filter, right? Okay. Now here you are having cos square term you are having. Okay, right. So this term I am writing. Okay, I hope all of you know this formula. Cos square A is nothing but 1 plus cos 2A by 2. 1 plus cos 2A is nothing but 2 cos square A. So from there you can write cos square A is nothing but 1 plus cos 2A by 2. 1 plus cos 2A by 2. Okay. So if you are using this particular equation here, okay. So from there what you will get? This term only I am considering only. Okay. Regarding the magnitude, that if we require we can consider later, but focus only this particular term. You are having cos square 2 pi FCT. Cos square 2 pi FCT. By using this equation, you will get 1 plus cos 2 into A. A is nothing but this entire term. That means you are going to get 2 pi FCT. 2 pi FCT divided by 2. Okay. So for the timing I am modifying like this. Okay, I am splitting into 2 terms. The first term is you are having 1 by 2. What about second term? You are getting 1 by 2. Regarding cos, I am copying as it is. But here regarding the internal term, I am just modifying in the standard format. Right? In general, whenever you are having cos signal, you are having like cos 2 pi FCT. Okay. So in that 2 pi F format I am bringing. Okay. So here I am copying this 2 pi. I am writing 2 pi first. Then here you are having 2FC into T. Right. So just observe 1 by 2. Yes, 1 by 2 we are getting. Then 1 by 2. Once again you will get. Okay, 1 by 2. Then cos 4 pi FCT. Here also cos 4 pi FCT, but I have represented in the standard format, 2 pi F format, 2 pi FT format I have represented. Now here you are getting, now can you tell, all of you please respond, whether these 2 terms will allow the band pass filter or will reject. Whether at least one of the term will pass, or both the terms it will reject, or both the terms it will pass. All of you please mention in the chart. Whoever watching this particular lecture later, you can mention this answer in the comment section. Whether the band pass filter which is having the center frequency of C, whether it is allowing both the terms or it is not allowing, or at least it is allowing one of the terms. All of you quickly respond. Yeah, some of you are saying that this particular term is allowing by the band pass filter. Whether it is really allowing. See, here 1 by 2 you are having. 1 by 2 is nothing but 0.5. It is a constant. So whenever you are having constant, it is having frequency how much? 0. So that means this particular term is DC term. This particular term is DC term which is having the frequency 0. Obviously 0 frequency here you are having. So obviously this particular term won't allow by the band pass filter. Right? Okay. What about this term? here you're having the frequency 2 times fc, 2 times fc. But here the band pass filter, the center frequency is fc, that means 2 fc somewhere you will be having here. 2 fc you will be having the far ahead of other than this band of frequency or range of frequencies you are having, right? So obviously that won't pass, that won't pass. Yes, very good Manoj, very good. Okay, so this is very high frequency when compared to this particular band of frequencies, right? Yeah. So obviously this particular term also, it is not allowing by the band pass filter according to this given question. So that means this overall term also not allowed by the band pass filter, right? Okay. So with this understanding, all of you give a try regarding this particular term, whether the band pass filter will allow or not. Similar format, same equation you can use regarding this particular term. All of you give a try, same equation, same equation. Cos square 2 pi fm into t, cos square 2 pi fm into t. So this one we can write as 1 plus cos 2a format, 2 into this entire term, 2 pi fm into t divided by 2. So this one I am splitting into two terms, 1 by 2 plus 1 by 2 into cos. Here also I am writing in the standard format, 2 pi f format, 2 pi into 2 pi I have written, then 2 fm into t, 2 fm into t. Now tell me, obviously this is the DC term, it won't pass, DC term won't pass. Now here you are having 2 fm as the frequency, whether this particular term will be allowed by the band pass filter or not. See, you can observe here, Fc is far greater than 5 times Fm. Okay, Fc is far greater than 5 times Fm. Okay, but as of now we got one of the frequency term as 2 Fm. That means 2 Fm will be having somewhere here. So this particular frequency is also not part of the band of frequency of the band pass filter, right? So that means it is not allowing. It is not allowing. So this term also not allowing, right? So with this understanding, in this particular term, the second term also not passed or not allowed by the band pass filter. Now, can you tell whether this particular term is going to allow by the band pass filter or not? All of you give a try. All of you give a try whether the last term is allowed by the band pass filter or not. Please quickly mention in the chat. Whoever watching this lecture later, you can mention answer for this question in the comment section. Yeah, some of you are saying that, sir, it will pass. Some of you are saying that it won't pass. Okay, you are having some dilemma, right? Okay, no issue at all. So regarding the standard equation, 2 cos A cos B, we already discussed earlier. 2 cos A cos B is nothing but what? 2 cos A cos B. We can write it as cos sum plus cos difference. 2 cos A cos B is nothing but cos sum plus cos difference. Right? Cos sum plus cos difference. Yeah, Manoj, yeah, you are saying that won't allow, right? Okay, I will mention. Okay, what is the correct answer? Okay. Here you are having 2 cos A cos B. 2 cos A cos B. Okay, right. So here you are having 2AC and then, Okay, cos 2 pi f ct, cos 2 pi fm into t you are having. Okay, that overall term I am writing here. Okay, AC I am keeping outside. Then 2 cos 2 pi f ct, 2 cos 2 pi f ct into cos 2 pi fm into t. AC I have kept starting. After that 2 cos 2 pi f ct, cos 2 pi fm into t. Cos 2 pi f ct, cos 2 pi fm into t. Okay, now you are getting the same format, 2 cos A cos B. Now you can use this trigonometric equation, right? By using this equation, I am keeping AC as it is. AC as it is. 2 cos A cos B is nothing but cos sum plus cos difference. Cos sum, that means you have to add these two terms. And difference means you have to subtract these two. Okay, so from these two you can take 2 pi as common. Then fc plus fm into t. 2 pi into fc plus fm into t plus cos 2 pi into fc minus fm into t, fc minus fm into t. Now just observe, whatever the equation here you are having, by using this standard equation, trigonometric equation, we are able to represent like this. Now with this understanding, you are having two frequencies. Here one frequency is fc plus fm, another frequency is fc minus fm. Whether, now I am giving one more chance for all of you, whether this ideal band pass filter, according to the given question, whether this band pass filter is allowing these two terms or not. I am giving one more chance. All of you can give it a try. Don't hesitate, just think and tell me. You can mention your answer in the chat, you can mention your answer in the comment section, whoever watching later. Okay, don't hesitate. What are the answer you feel correct, you can mention. See, here we got two frequencies, right? One is fc plus fm, another one is fc minus fm. Here the center frequency is fc, and the pass band width they have mentioned 3 times fm. So with that understanding, can you tell what is this frequency? What is the upper cutoff frequency for this band pass filter? Similarly, can you tell what is the lower cutoff frequency for this band pass filter? Here 3 fm, that means this side you are getting 1.5 times, this side you are getting 1.5 times fm, right? So that means this frequency is fc plus 1.5 times fm. Yes or no? Similarly, this one you are going to get fc minus 1.5 times fm. Okay, I have given more hint. Okay, at least you can answer now. Here you are getting fc plus fm. fc plus fm, where you are getting? Here fc plus 1.5 fm. So you will be having fc plus fm somewhere here. Yes, very good. Similarly here fc minus fm you are having. So this is fc minus 1.5 times fm. So obviously somewhere here you will get fc minus fm. So that means fc plus fm and fc minus fm, those two frequencies are falling in this particular band of frequencies, right? Yes, very good Manoj, very good. Yes. So this particular band pass filter finally allowing three terms. One is this carrier frequency component, that is fc. Another one is fc plus fm, that is the upper sideband frequency, and other one is the lower sideband frequency, that is nothing but fc minus fm, right? So here those three components, frequency component terms, it is allowing. Okay, so even actually some of you told earlier that the last term of the earlier output of nonlinear device. Okay, so some of you told that that last term the band pass filter is not allowing. Okay, so even if you felt like that, whether your answer is correct or not, okay, if you are able to read this question carefully and understand this question carefully, then at least that will give you the like if you are applying your common sense, at least from there you can avoid such kind of silly mistakes during your real GATE exam. Okay, so in this question, what clue they have given? Whoever mentioned earlier that the ideal band pass filter for this question, whoever mentioned earlier, the last term is not allowing. Okay, no issue at all. Okay, due to any reason you might have mentioned that this last term is not allowing by the band pass filter, right? You have mentioned. Okay, so now I am giving the hint in this question. What is the hint? If you are using that particular hint, you can decide whether the last term is going to allow or not by the band pass filter. Even if you are doing some silly mistake due to any reason, you can avoid such kind of silly mistake. Okay, what is the hint present in this entire question? After reading, you are having one hint. With the help of that hint, you can decide whether really you know or not. Even with that also, you can decide whether the last term you have to consider or not. What is the hint present in this entire question? I hope all of you can answer. It is very simple. I am mentioning hint, but that hint is like not the secret one. They have mentioned clearly in the question. There is no hidden secret. It is the open secret, I can say. That is why I am telling hint. See here, whatever the nonlinear device you are having, for that nonlinear device, they have given the input signal as C of t plus m of t, and the output of nonlinear device, they are passing through ideal band pass filter. And what is the main objective? The output of the band pass filter they want to get in order to produce an amplitude modulated wave. That means the hint in this particular question, they have given the AM wave. That means whatever here entire sentences they have mentioned, that is completely related to AM generation. So whenever AM, amplitude modulated signal you are having, that means it will be having 3 frequency components. Yes or no? So earlier, with the help of general observation, by observing the frequency terms, you have guessed that this particular first term is allowing, right? This second term you have rejected, third term you have rejected, fourth term you have rejected. Now regarding fifth term also, some of you told that earlier the fifth term, the band pass filter is not passing. Okay, suppose if your assumption is correct, then that time what will happen? At the output of nonlinear device, you are going to get only the carrier frequency component. You are going to get only FC component, right? But the question is what? With the help of band pass filter, we are going to produce AM signal. Okay, in the AM signal, you will be having 3 frequency terms. One is FC, another one is FC plus FM, another one is FC minus FM. So if you are able to apply that hint, then definitely you will say that, sir, this particular term is going to allow by this band pass filter. Because if the moment if you are saying no, that means you are getting only the carrier frequency. That means it is not producing AM, right? So, and for understanding purpose, I have discussed with the help of standard trigonometric equation how this last term also passed by the band pass filter. For that understanding purpose we have discussed. But in the exam, if you want to save the time, you can, wherever hints are there, just apply those hints. Then definitely, even without solving the question completely also, with the help of partial understanding also, you can easily attempt the questions in less time, right? Okay, I hope all of you got the clarity up to here. So finally, this is the overall equation you are having at the output of nonlinear device. But among this entire equation, only the first term and the last term, is passed by the band pass filter, so that you are going to get AM signal, right? So whatever the AM signal you are going to get at the output of band pass filter, that equation now I am writing. Okay. Output of band pass filter. So here the first term, if you observe, A into AC cos 2 pi f ct, right? A into AC cos 2 pi FCT plus last term here you are having this entire term, and for this entire term you have to multiply with B, right? So multiply with B and write this overall term. So you are going to get 2BAC 2BAC B into 2AC, that is nothing but 2BAC, then cos 2 pi FCT cos 2 pi FMT, right? Cos 2 pi FCT into cos 2 pi FMT. Okay, right. So from these two we can take this entire term. I am taking it as common so that we can get the standard equation of AM signal. AC cos 2 pi FCT I am taking common. Then since I have taken this entire term common, so here obviously we can write only 1, because 1 into this entire term is nothing but this term. Now here AC I have taken common, then cos 2 pi FCT I have taken common, okay, and then you are having 2B cos 2 pi FMT, okay. So AC cos 2 pi FCT is there, but A is not there. That means here this 2B I am copying as it is, and in the denominator I am writing A. Now multiply both, A and A both will get cancelled, 2B, yes we are getting, and then AC cos 2 pi FCT, and then you are having cos 2 pi FM into T, cos 2 pi FM into T. Now you can compare this equation with one of our standard equation. Here you are getting small a also you are getting, but in general you will be having AC cos 2 pi FCT into 1 plus mu cos 2 pi FM into T. Okay, so for the timing if you want, you can represent this overall equation, this overall term like A into AC, you can represent as AC dash, okay. So for the timing I am representing like AC dash. In general you will be having AC, but since you are having some extra scaling factor, so for the timing I have labeled like AC dash, okay. And then you are having cos 2 pi FCT into 1 plus mu cos 2 pi FM into T, 1 plus mu cos 2 pi FM into T. So when you compare these two, you are going to get modulation index as 2B by A, okay. Modulation index you are going to get 2B by A. Is it clear for everyone up to this step? If you are having any doubt, you can ask. See, the previous question and this question both are related to the same concept, but only the difference, in the previous question they have given directly AM equation, but in this question they are going to produce the AM equation. For that they have given the steps. So if you follow those steps, from there we are able to get the standard equation of our AM signal, right? Okay. Now let us proceed further. In the question what they have mentioned, if it is desired to have the sideband power, yes, yeah, if it is desired to have the sideband power, that means see whenever they mention regarding AM, yes, very good Manoj, whenever they mention regarding AM signal or DSBS signal, so whenever they mention message signal or whenever they mention sideband, that means you have to consider total sideband, okay, unless otherwise they specifically mention like single sideband, okay, right. So whenever the question is related to SSBSC, that means obviously sideband means single sideband only, but whenever the question is related to AM or DSBSC, whenever the terms related to message or sideband they mention, that means you have to consider both the sidebands, okay, right. Here they are asking the sideband power, that means the total sideband power of the AM, okay, wave to be half of the carrier power. So here they have mentioned the total sideband power is equal to half of the carrier power, right. Total sideband power is nothing but PC mu square by 2, okay, which is equal to, according to this question it is PC by 2, okay. So 2 will get cancelled, PC will get cancelled. From here you are going to get mu square equal to 1, mu square equal to 1. Okay, so from here you will get mu value as 1. So substitute mu value, just now you got 2b by a. 2b by a equal to 1. So with this understanding, all of you give the answer for this question. They are asking the ratio of a by b. Ratio of a by b they are asking. All of you give a try. It is very simple. I hope all of you can answer easily. Yeah, just do the cross multiplication, that's all. So here, if you do the cross multiplication, here according to the question, requirement is a by b, right? So a will come into the numerator, b will come into the denominator. After that, here left hand side you are having 2. So a by b equal to 2, right? So that means the correct answer for this question is option D. Option D is the correct answer. Option D is the correct answer. See, in the previous question they asked the ratio of message signal power and carrier power. In this question they have given the relation between the total sideband power and the carrier power. Okay, they have mentioned that total sideband power is half of the carrier power, right? After that you are getting one relation. From there they asked the one relation like ratio of a and b, that's all. Okay, so for this question the final answer for this question is 2. Okay, right. See, earlier I have given one hint whether the last term is going to allow by the band pass filter or not. Okay, and one more hint I am giving. Whenever you are having AM signal, you are having like this, right? AC. Here in this question I have mentioned like AC dash, but in general you will be having AC cos 2 pi f ct into 1 plus mu cos 2 pi f m into t, right? So when you multiply this term individually with these two terms, from the first term you are going to get the combination as simply carrier signal AC cos 2 pi f ct, and then another term what you are going to get mu AC into cos 2 pi f ct into cos 2 pi f m into t. Okay, so that means the moment if you are erasing the first term, okay, after doing the multiplication of the first term with these two, okay, then in that equation if I remove the first term, then what about the second term is going to represent which equation? Any guess? Yes, obviously, say for example, here you are going to get what? AC cos 2 pi f ct into mu cos 2 pi f m into t. Okay, so that means in simple words, okay, mu AC, you are getting some scaling factor, forget about that one. Okay, you are getting like cos 2 pi f ct into cos 2 pi f m into t. That is nothing but what? Just simply you are multiplying message signal and carrier signal, which is nothing but double sideband suppressed carrier. Okay, here in this equation you are having both the sidebands, along with that carrier is there, that is nothing but AM signal, right? So in that way also you can identify easily that whether this particular term is going to allow or not by this band pass filter, because they have clearly mentioned that it is going to produce AM signal. Obviously in that AM signal you should have 3 frequency components. One is related to the carrier frequency component, and other one is upper sideband frequency, another one is lower sideband frequency, right? In that way also you can correlate. Okay, right. So both the questions are related to the same concept only, and interestingly both the questions they have asked in the same year, same branch. Okay, so that's why whenever you are learning any concept, okay, so definitely that method will help you for solving similar kind of questions in your coming GATE exam as well. Okay, right. So for the timing I will stop here, but before ending the session, in this particular year I am going to show the next question, but I won't solve this question now, but I am giving this question as a homework. So all of you kindly solve this question, and whatever the answer you are getting, okay, in your free time, okay, mention the answer for this question in the comment section. In the tomorrow class, tomorrow we are having the live session at 2 o'clock. So in that session, at the beginning, I will discuss this question, and then we'll move on to the selected questions of 2017. Okay, GATE questions which are asked in the year 2017. Okay, right. So all of you just take the screenshot of this question. I am giving this question as a homework. All of you mention, give a try. Whatever the answer you feel correct, you can mention in the comment section, right? Is it clear, Manoj? Do you have any doubts? So all of you kindly take the screenshot of this question and solve in your free time. And in tomorrow's session, we are going to start the session at 2 o'clock. Okay, so before, you are having the time till 2 o'clock tomorrow, right? So before that, okay, try to solve this question. What is the answer you are feeling correct, you can mention in the comment section. Even whoever watching this particular lecture later, no issue at all. Okay, so just give a try, and whenever you are seeing this particular question, just solve by your own before watching the next session, right? And you can mention your answer in the comment section. Okay, right. So with this, I am concluding this session. We'll meet you all on tomorrow at 2 o'clock. Thank you, everyone.